Hey everybody, it's Mr. DuBois here. We're in Unit 3, Functions. So what we're going to do is we're going to be looking at real-world applications of, whoops, there goes my face, of graphs here. So we have a graph, and it says, example one, an epidemic of influenza spread throughout a city. The figure below, that little graph right there, is the graph of f of w equals I, where I is the number of individuals in thousands infected. Okay, so going up right here, this is people, and that's in thousands. Okay, so that means right here, this is 2,000, this is 4,000, 6,000, 8,000 people infected. This example is kind of pertinent to the world we were living in last year. And it says infected W weeks after the epidemic. So this down here is weeks. Okay, this is weeks. So we've got 2 weeks, 4 weeks, 6 weeks, 8 weeks, 10 weeks, and so on, okay? So this graph kind of tells us how many people have been infected as we go on. So at 16 weeks, this is how many people infected and so forth. So part one, it says estimate f of 2. So we just learned function notation. So the number inside of here is our x coordinate, our x value, but in this case it would be w. So what this is saying is find 2 on the graph. It's way up here. Okay, and it's asking how many people. Okay, so that would be 7,000 people were infected after 2 weeks. Okay, so f at 2, we just got done evaluating graphs. So this is our x value. Go to x is 2. Find out what the y value is. It'd be 7 or 7,000 people. Part B says explain the meaning of 2 in terms of the epidemic. So after 2 weeks, 7,000 people are infected. Okay. So it told me in the beginning, these down here on the x axis were weeks. Here's people in thousands. Okay. So the next example on your notes. Okay. So again, these are people in thousands. Okay. These were weeks. So it says approximately how many people were infected at the height of the epidemic. Okay. So it's asking how high did it get? Well, it's way up here. I don't know. It looks like it'd be about, and it's approximate, about 8,500 people. Okay, and it's approximate. It's a little bit over 8,000. Like here's 8,000. It's a little bit over. There's 8,500. And when did it occur? When was it the most? It's a little over 3 weeks. 8,000 right about. Okay, so that's like during the 3rd week. Okay, during the 3rd week, you could say 4th week, I'd give you credit, but we're just reading this graph. Okay, so we know this is weeks. These are thousands of people. We're just answering these questions. So here in the 14th week, we had about a little over 2,000 people infected. Okay, so that's your notes. If you're doing this course in Edmentum, this is what an example problem is going to look like. I do want to go through one example problem. You don't have this on your notes to write, so just listen and watch. So it says cross-country skiing distance goals. So Jake is in purple here. Jake's goal at the start is to be able to go 2 kilometers, it looks like. And it looks like Jake at the 1st week wants to go 2.5 kilometers. Jake in purple, after 2 weeks, wants to be able to cross-country ski 3 kilometers, and so forth. And the graph looks like Ralph in blue here. His goal the whole time is just to be able to go 4 kilometers. So it says which statement is true about the two skiers. Statement 1 says Ralph plans to end up skiing more than Jake. Okay, well, at the end, Ralph only plans to ski 4. Well, at the end, Jake plans on skiing 6. So that's not true. It says Ralph starts off skiing more than Jake. Remember, Ralph is blue. Jake is purple. Ralph is above Jake, so this is true. Let's look at the last one. It says Ralph plans to increase his skiing distance more than Jake. This is not true. Ralph does not plan on increasing his skiing, while Jake does. So, not true. And that's it for this set of notes.